Hi everyone. Today we will be working on double displacement. Our goals for today is to be able to name the type of reaction by looking at the chemical equation, balanced chemical equations, specifically double displacement, and predicting the products of each type of double displacement reaction using the solubility chart to determine if a double displacement reaction will occur. Okay, so last year when you were looking at double displacement, you were introduced to this general equation. AB plus CD will produce AD plus CB. So the cation will replace the cation, or the anion will replace the anion. Okay, you can choose, but basically they swap places. A way to remember it is take a look at this picture, right? People are dancing and then they switch partners. Okay, so let's talk a little bit more about double displacement. And this year in grade 11, you will be learning how to predict the states of each compound in a chemical reaction. Okay, so both reactants are combined, which have a cation, A and C, as well as an anion, B and D, in the above general equation. We need to be aware of three different variations of double displacement reactions that are listed below. Precipitation, okay, this is when one of the products will be a solid in solution. So what we write for short form for precipitate is PPT. Sometimes you'll see that I'll write it on the board, but your state is solid whenever precipitate forms. There's also gas production, when one of the products will be a gas. Okay, so if something is a gas, your state is a G beside it. Okay, neutralization will be its own lesson, okay, when we talk about acids and bases, and then you'll see it again in unit form. Okay, so don't worry too much about number 3 until we reach that lesson. Okay, today we're just going to talk about double displacement precipitation reactions and double displacement gas production. Okay, so if you watch this video, first pause this video to watch the video linked in, where a solution of silver nitrate will react with a solution of sodium chloride to produce sodium nitrate and a silver chloride precipitate. While you're doing this, I want you to really watch. Does a solid form, or do they remain aqueous, meaning dissolved in water in solution? Okay, so pause my video now and click on the attachment and predict your balanced chemical equation as well as the states. Okay, so for silver nitrate, that is AgNO3. Okay, you should have seen in this video that nitrate, when combined with silver, it is aqueous, right? It is in solution. Then you have a solution of sodium chloride. It even tells you in the question. So that means the state has to be aqueous. Okay, it will produce sodium nitrate. Okay, which remains in solution form, so aqueous, and it will produce a silver chloride precipitate. Okay, soon as we see precipitate, you have to write the state to be solid. Okay, very important, right? That solid is because it is precipitate. Okay, then you want to double check, is it balanced? And yes, we are balanced for this equation. Okay, so something very important to note. A solution is a homogeneous mixture, okay, meaning it looks like one mixture, it looks like one liquid of a solute dissolved in a solvent, meaning that in that mixture there's more than one something inside, okay, but it looks like one. Okay, for example, an aqueous salt solution is a mixture of salt, which is the solute, okay, dissolved in a solvent, which in this case would be water. So when you're boiling, when you're preparing to boil some water for your pasta, you're adding salt to your water. Okay, and that is a homogeneous mixture once the salt has dissolved in the water. Okay, so chemists will describe a substance as being very soluble or highly soluble if a significant quantity of the substance dissolves. So on the contrary side, A substance that does not dissolve well is only slightly soluble. So almost very, very, very barely soluble. So only a little bit will dissolve, the rest will not. Okay. So in the equation of a precipitation reaction, state symbols will indicate which of the products form as a precipitate. Okay. The state symbol S in brackets indicates that there is a precipitate. Okay. Sometimes I'll write precipitate as PPT. Whereas when the symbol is aqueous, it tells you that it is highly soluble and the substance remains in solution. Okay. So let's just take a look at what that looks like based on the example above. We're just going to look at the products. Okay. If I have, and I'm going to draw this out visually to help you kind of see what happens. Okay. So here's my beaker of silver nitrate. It's aqueous. So you have ions floating in solution, right? Because it is aqueous. Then I also have a beaker or something in maybe a dropper bottle of NaCl. If I were to do this in a lab, okay? So we have these ions floating in solution, right? Because it's dissolved in water. They are aqueous, okay? Now, what ends up happening when we mix the two together, okay? So when we mix them together, okay, what happens to these ions, okay? So what you'll see is that sodium nitrate is aqueous, meaning your sodium ion stays the same, it's still floating in solution. So does your nitrate ion, okay? But what you end up seeing happen is all of a sudden you'll observe some sort of solid forming, and that solid is the precipitate of AgCl. Okay? So that's kind of a little bit of a visual of what you would see and what you watched in the video. But really important to remember that when something is aqueous, that means its ions are they're floating in that solution, right? It's dissolved. It is very highly soluble. So you'll see your elements in ion in ion form. Whereas if something is solid or precipitate, it'll actually, if you were to do the lab, you would see the physical solid being formed. Okay? And we'll do kind of a lab to visualize that soon. So, how would I predict the states? Okay? If you look at the back of your periodic table, on the back of your periodic table on the data sheet, you're going to see this wonderful big chart. Okay. On this chart, you have high solubility, and I want you to write aqueous beside it to remind you that that's the state, meaning it's very highly dissolved in solution. You'll also see low solubility, and that's at S, right? That to remind you that a precipitate has formed. So please pause this video, annotate your periodic table, the data sheet on the back. So for now, you get used to that, okay? Now, how do I read this solubility chart? Well, you need to figure out which anion is mixing with which cation. So let's say I'm trying to figure out, does fluorine, when I do a double displacement reaction, does fluorine will fluorine form an aqueous solution or a precipitate with lithium? Well, if I see fluorine right here, okay, I see fluorine right here. And with lithium, well, lithium is right here. So it's telling me, because lithium has low solubility with fluorine, it is very, very, very little amount will dissolve. Most of it will not dissolve. It will not be soluble. Okay, so that's why we say slightly soluble, but we have to put the state solid because it is a precipitate. Okay, and we'll do some practice examples of how to read this table. So if I go back to our lesson, here again is this solubility chart. Make a note for yourself. The solubility chart is sorry, that's my dog barking. It's the back of your periodic table. Okay, and you will always be given this on a test, right? You'll always get your data table. Okay, so reminder, high solubility, aqueous state, low solubility, solid state, because it forms a precipitate. So let's use this chart to predict the products with calcium chloride reacting with sodium hydroxide. So if I have calcium chloride reacting with sodium hydroxide, right, either switch your cations or switch your anions. So for me, I'm just going to swap my cations. So I would have a solution of sodium chloride, okay, as one of my products, and I would have calcium hydroxide. Okay, now how would I write my chemical formula? Sodium chloride is NaCl. Okay, and calcium hydroxide is Ca bracket OH bracket 2. Okay, because calcium is a charge of 2 plus. Now let's write this as a balanced chemical equation. So I have sodium chloride. Oh, sorry. We're first looking at the reactants. We have calcium chloride. Okay, I'm going to leave a space for the states. We'll come back to it. Plus sodium hydroxide producing, oops, we forgot our brackets for the states. We have to get used to that. Okay, producing sodium chloride. Leave room, some brackets for the states. Okay, and calcium hydroxide. And again, brackets for the states. Now, let's take a look at each state. For calcium chloride, chlorine is right here. If I don't see calcium anywhere here, that means it falls into this category of most, so high solubility. So it has to be aqueous. Okay, sodium hydroxide. So we look at our hydroxide. Here's our hydroxide. Sodium is a group 1 metal, right? Your group 1 metals are your alkali metals. Okay, so it is highly soluble. So our state here is going to be aqueous. Okay, usually for double displacement reactions, you need to have your reactants, they will be in aqueous state because we need to be able to mix them together. And they need to be in ion form. Okay, now the trick is to look at your products, right? Because this you actually have to be able to predict what kind of state it would be. So let's say now I'm going to take a look at my NaCl. So now I'm looking, okay, well, I have chlorine right here. Where's sodium? Well, it's nowhere here again, so that means it's mostly, whoops, it is mostly soluble, so my state is aqueous. Okay, now calcium hydroxide is the next one I'm going to take a look at. And let me use a different color. Let's use gray. Okay, so here's calcium. Oh, sorry, here's hydroxide. Okay, where is calcium? Well, calcium is not an alkali metal. It's an alkaline earth metal. Okay, it's not ammonium, it's not strontium, it's not barium. So it's nowhere in here. So calcium would be in this group of low solubility with hydroxide. So our state in this case has to be solid, right? Reminder that solid state means there's a precipitate. Okay, and you'll also see that as we continue doing these predictions of states, if nothing changes, so if just your elements rearrange places and all of your states are aqueous on the reactant side and the product side, well, then no reaction has occurred because they haven't formed new products. And I'll show you that later on. Okay? So looking at the chemical equation, we need to double check, is it balanced, right? That's always our last step. Well, we have one calcium here, one calcium on the product side. We have 2 chlorine. So we need to put a 2 there. Okay. Sorry. We have 2 chlorine and we have 2 chlorine. So you're going to put a 2 there, which makes us have 2 sodium. So I have to put a 2 there. And now we have 2 hydroxides on both sides. So yes, now we're balanced. Okay. Now let's do our word equation. We have sodium chloride plus calcium hydroxide. Sorry, I keep looking at the products chart. We have, hang on, let's try. We have calcium chloride plus sodium hydroxide, producing sodium chloride, plus calcium hydroxide. Okay, and yes, a reaction occurs because you know that this is your precipitate. Okay, that's your solid. So let's try one more together, and then I will wrap up this video, and you can practice on your own and check your solutions for the rest of the worksheet. So predict the products when silver sulfate reacts with potassium iodide. Okay, so my reactants are silver sulfate, right? That's a polyatomic. You're all memorizing these as you go because you on the test you need to know them. So I have silver sulfate, okay, AgSO4. Okay, check your charges. Sulfate has a charge of 2 minus, so it's Ag2SO4, and potassium iodide, so Ki. Okay, now the products, again, either swap your metals or non-metals. This time I'm going to show you how to just swap your, in this case, your anions. Okay, so you're going to have your products to be silver iodide and potassium sulfate. Okay, now silver iodide is AgI because they have a charge of +1 -1. Potassium sulfate is K2SO4. Okay, so let's write out our equation. Okay, so I have AgSO4, leave space for states, plus Ki, producing AgI plus K2SO4. Again, always now, from now on moving forward, write your brackets and predict your states. Now, let's take a look at our states. Okay, sulfate, is it soluble with silver? All right, let's take a look. So where is sulfate on here? Sulfate is right here. Is it soluble with silver? No, it is not. It is low solubility. It is solid. Okay, then you have Ki, which is potassium iodide. So iodine is right here. Okay, and potassium falls into this category, so it is aqueous. Okay, and then we have AgI. So again, iodine with silver is going to be solid. Okay, that's your precipitate. And K2SO4, here's SO4. Potassium falls into most, so that has to be aqueous. Okay, so remember then, last but not least, check, is it balanced? Okay, I have one silver on the left. Oops, sorry, it should be Ag2SO4. Okay, there should be two silvers because the charge of SO4 is 2 minus, so Ag2SO4, meaning I have two silver on the left, and on the right I have one, so I have to put a 2 right here. Now I have 2 iodine on this side, on the product side, so I need 2 iodine on the reactant side, and then I have 2 potassium on the reactant side, 2 on the product side, and a sulfate on both sides. So yes, we are now balanced. All right, so I'd like you to try the next, oh, we forgot the word equation. I'm going to let you do the word equation by yourself here. Okay, and then you're going to proceed to do the practice for the rest of the worksheet for precipitation. Okay, now another part we have not talked about, okay, is gas production. So this is a type of double displacement. More specifically, there's gas produced. So some double displacement reactions will produce a gas, right? So our state is G rather than a solid precipitate, right? There are specific reactants that will combine to create a specific gas as outlined below. These will need to be identified in order to correctly predict the products. Okay, so here's your list. carbonates produce carbon dioxide in some reactions. Okay, you have seen this in synthesis and decomposition. Okay, so that might be a way you remember this. Sulfates produce sulfur dioxide in some reactions. So this is new, very new. We have not seen this before. Okay, ammonium salts will produce ammonia in some reactions. Now, ammonia is NH3. Okay, its proper name is nitrogen trihydride. Okay, however, we call it ammonia. It's a common name that you might even recognize. Whereas ammonium, that is your polyatomic NH4 plus. Okay, and then this is also very new to you. And sulfides will produce hydrogen sulfide in some reactions. Okay, this is also new to you. So you're going to need to use this table for the first little while you are doing double displacement. Eventually, these will come second nature to you. Okay, look at the examples on the side. Again, remember this is gas production. So this is where you're seeing a gas being produced in this double displacement reaction. Okay, and you'll see I've added that the carbonate would react with an acid to produce carbon dioxide and water because we need that hydrogen from the acid, right? Your acid is some sort of hydrogen ion attached to an anion, if you recall from last year. Okay, same thing here. And then for your ammonia salts, you're looking for something with a base. Okay, so some kind of base that is with a hydroxide specifically. Okay, because that's where your oxygen for the water and your hydrogen will come from. And again, for the sulfides, it will be some kind of acid that will be part of your reactants to get to the gas as a product. So let's practice a little bit with precipitation that you can do by yourself. Okay, what I want to add here is let's do some practice with gas formation. Okay, so I have Na2CO3. Okay, right away I should recognize that I have CO3, that is a carbonate. Okay, and it's reacting with some kind of acid. Okay, now we can scroll back up if we don't remember. Carbonates produce carbon dioxide in some reactions. So when it's reacting with an acid, products are CO2 and H2O. Okay, so I want you to try this one out. So we need some kind of carbon dioxide, right? Because that's from the carbonate. Okay, you will also have a water produced. Okay, and then you'll notice, okay, you're still left with a chlorine and a sodium that you do not see on the product side. Okay, so that means I want you to pause and think, what does that mean? What do I need to do for this reaction? Okay, well, your NaCl will actually combine to form NaCl on the product side. Okay, then you also have to make sure you include your states. CO2 is a gas, water is a liquid, and NaCl, if you look at your solubility chart, is aqueous. Okay, you also need to make sure you're balancing everything. Okay, so you would have to add a 2 right here. I forgot to remove it because you have 2 hydrogens on the product side, and you also have 2 sodiums on the left, and now 2 chlorines on the left, so you have to add a 2 there for sodium chloride. Also, though, notice that my CO3 has broken up into water and carbon dioxide. So here are my 2 oxygens, and here's one more. So there's the 3. So yes, oxygen is balanced in this case. Okay, so we're balanced, and I'm going to encourage you to continue trying the next. Again, gas formation is a little bit more challenging. You'll learn to recognize it. Okay, so notice here we have ammonium, right? One of your products will have to be ammonia. Here we have a sulfate, okay, and so on. So do this practice, but refer back to this handy little helpful chart. Okay, come to class with questions, and thank you so much. Have a lovely evening.